Hi everybody, welcome to test 1 review in calculus 3. On the top you will see the topics of the question that we need to go over. Right, let's start. First we have operation on vectors. So pretty much we just have the vectors and we do the combination of the vectors. So this just -3 times vector u minus vector v. Right. So -3 times 2, 6 minus vector v, 2 and -8. And we just multiply the numbers into each component of the vectors. -6, -18. And then we subtract the vectors, so we subtract the components. -6 minus 2 is -8, -18 minus -8, so plus 8 was -10. Right, so that's what we have. And I will update the list of the question. This is number 1. And that is that. Right. Next we have the equation of the sphere given by the center and the radius. Before we go to 3, I just finish this one real quick. To find the vector AB, A is this point and B is that point. So to find the vector AB, we take the end point minus the initial point. So final minus initial, the head minus the tail. So B -3, -13 and 4 minus point A so -3 minus -8, so that is +5. -13 minus -6, -13 plus 6, -7, and then 4 minus 1 is 3, and we can write that as a component. 5 -7 and 3, or 5 times I minus 7 j and 3k. Right, so that is how we find the vector connecting the 2 points. Right. Next, find the equation of the sphere given by given center and radius. So the equation of the sphere is x minus a square, y minus b square, plus z minus c square equal to the radius square. So in this case we have the center at this point and radius 6. So all we need to do is just replace a is 0, b is -2, and z is -1, and radius is 6 square. So we have x square plus y square plus z, sorry, that was y plus 2, x square y plus 2 square plus z plus 1 square equal to 36. And we can just leave the equation in that form, which is better because from here we can say what is the radius and what is the center. So just leave the equation in that form. Next we have the unit vector. The unit vector is the vector that has the length equal to 1. So this we have number 5 here. So the unit vector in the same direction as v, which means what we need to find is the vector v divided by the magnitude of the vector v. So that is the unit vector in the direction of v. Right. So we're going to find that. The vector is negative 24, 24, and negative 12. Over the magnitude, negative 24 square, 24 square, and negative 12 square. We still have negative 24, 24, and negative 12. Right. I'll just use a calculator real quick. Right. 24 square, 24 square, and 12 square. And square root of that is 36. So we just have 36. And so we have negative 24 over 36. Oh, sorry. Cannot see it with the calculator. 24 over 36 and negative 12 over 36. So that gives us negative 2 over 3i, 2 over 3j, and minus 1 over 3k. We can leave the answer in ijk, or we just have negative 2/3, 2/3, and negative 1/3, either in the components form or in the ijk form. Right. So that is the unit vector in direction of a vector, another vector. Right. Next we have the dot product. The dot product formula itself is pretty simple. We just find the sum of the products of the components. So v dot u equal to v is 2 and negative 3, and sorry, this v dot, v dot u, so 2, negative 3, and negative 8, negative 5. Dot product, multiply the components and then add those products. So here we have negative 16 and 15, that gives us negative 1. That was 6. So that's just the dot product. The dot product has two applications: angle between the vectors and the orthogonal projection. We're going to go there. So find the angle between u and v in radians, right? So in general, actually this is the definition of the dot product. U dot v equal to the magnitude of vector u times the magnitude of vector v times the cosine of the angle in between. Because of that, if we want to find the cosine of the theta, it is equal to u dot v over the product of the magnitude right. Now just go ahead and use that. Cosine of theta u dot v, this is u and this is v. Notice there's no I component here, so we're going to have 0, 3 and negative 8 dot 9, negative 5 and negative 8 times the product of the magnitude. We have 3 square and negative 8 square, 9 square, negative 5 square and negative 8 square. Right. We do the dot product first. 0 times 9, that's 0. 3 times negative 5, so negative 15. And negative 8 times negative 8, that's 64. Right at the bottom. 3 square and 8 square. 3 square is 9. 64. It's 73. I'll just use a calculator. Right. Nine square, 5 square, and 8 square. 170. And on the top, so this is 15, 64, 49. Right. And the bottom is, I just say 73 times 1 square root of, so pretty much that. Again, move the calculator here. Right. And then we just find the cosine inverse to get back to the angle. So second cosine inverse, make sure this is in the radian mode. So it is in the radian mode, which is good. Second cosine inverse of fraction 49 over square root of 73 times 170. At 1.12 radian. Right. So the dot product, the cosine of the angle between the two vectors, and then we check the cosine inverse. So that is, if we write equal like this, it doesn't make any sense. So let me change the notation. So theta equal to cosine inverse of 49 over square root of 73 times 170. Yeah, so that's what we should have. So find the cosine of the angle between two vectors and take the cosine inverse, and we have the angle. So we're doing the dot product here. That we have 6 to 8. And now we do the projection. The projection of a vector onto another one. This is u onto v. So projection of vector u onto vector v is equal to u dot v over the magnitude of v squared times the vector v. So we have v, v, and v squared. Vector u only appear once. Right. So we have u dot v. U is 2, -2, -4 dot vet. That was v. So this is u. 5, there's no j, and there's k. Times vector u, 2, -2, and -4. Right, over the magnitudes of v squared, 2 squared, -2 squared, and -4 squared, times the vector v, 2, -2, and -4. When we do this, all of this will give us just a number, and then that number will multiply by the vector. So the dot product, we have 5 times 2, so that is 10, plus 0 times -2, that's 0, and -12, -4, that's 48. The bottom, 2 squared is 4, 4 squared is 4, 2 squared is 4, 4 squared is 16, so square 24, and square root and square cancel out. So here we just have 58 over 24, 2, -2, and -4. Right, and then we multiply that number to everything. So 58 times 2 divided by 24. So 58 times 2, 116. Over 24. -116 over 24. And 2, 32 negative over 24. Right. All that divisible by 4. I reduced by 4. So it'll be 29 over 6. -29 over 6. And 232 just use a calculator. 232 divided by 8 with 29 over 3. Right, so that is the orthogonal projection of u onto v. So the dot product of u and v over the magnitude is v squared times v. So that just gives us a number times a vector v, and that's what we have. Then we have a problem application. This is the dot product because this is identify the work done to slide a box 33 meters long by pulling it with 133 pounds of force, 133 Newton force at an angle of 45 degrees. So this is pretty straightforward. All we have is the work is equal to the force dot the displacement, the force that move an object in that direction, which is the force magnitude times the magnitude of the displacement vector, and then the cosine of the angle between them. So the force of the vector is 133 Newton. It goes 33 meters, and the angle between them is 45 degrees. 133 times 33. 4,389. Cosine of 45 degrees, square root of 2 over 2. And the unit is joules. So I just multiplied by square root of 2 over 2. It is about 3,103.5 joules. Right. So that is work. The work done by the force moving an object in the vector D, displacement vector D. Right. So that is that. Next we go to the cross product. Cross product. The cross product, we're going to find the cross product using the 3×3 determinant. So this time, be careful when we find a dot cross product. Cross product is not commutative. So if we ask to find U cross V, and we find V cross U instead, it's going to be opposite. So it's very important that we have to keep the right order of the vector. Right. So this is U cross V. So U cross V. It is the determinant of a 3×3 matrix. The first row is the IJK component. The second row and the third row are the matrix, are the vectors 2, 2, and -1. That's for U. 2, 2, and -1. And for V, -1 for I, -1. No K, no J, and 1K. Right. So to do this, we're going to cover the row and the column. So we'll cover the row and the column that containing I, and then J and K. So that covered of that row. So the first one, we covered I as well. So the row and the column containing I, we have 2, -1, 0, and 1. Whatever we have, we multiply in the I direction. For J, we have 2, -1, -1, and 1. That is in the J direction, but it's very crucial that in the J direction it is going to be minus. So it's going to be plus, minus, and plus. And then for K is the plus 2, 2, -1, and 0. That's for K component. Right. So that's how we evaluate a 3 by 3 determinant. Now we do the 2 by 2 determinant, multiply and subtract. So that gives us 2i. And then next, minus 2, 2 minus 1, so that's just 1, 2, that's just 1 times 2 minus negative 1 times j, and then 0 minus negative 2, so that's plus 2k. So we can write the vector as 2, that is 2 minus 1, so it's 1, 2 minus 1, and 2. Right. So that is the cross product of u and v. Let's go back to the question. Find the magnitudes of u cross v and the unit vector parallel to u and v. I think there's one on. Right. So next we find the magnitude of u cross v will be the square root of the sum of the square of the components. So 4, 4 and 1, so that is square of 9, which is 3. Right, so that is the magnitude. So we found the magnitude. And next we find the unit vector in that direction, which means u cross v over the magnitudes of u cross v. So we have the vector 2, negative 1 and 2 over the magnitude, which is 3. Right. So that's just 2 divided by 3, negative 1, 3, and 2 over 3. So that is a cross product. And in general, if we have two vector u and v, on a plane, when we do the cross product, we're going to have the vector that is orthogonal to both. In this case, the right hand rule u and v. In this case, the vector u cross v pointing down. So u cross v and then pointing down. But the cross product is orthogonal to both of the vectors u and v. Next, we're going to use the cross product to find the area of a parallelogram or a triangle. Right. This time we have a triangle, which is easier than the parallelogram. So let's just sketch. Don't have to sketch exactly the point, but it will be P, Q, and R. So what we do is we're going to find the vector PQ, because we know 2 points P and Q. We should know the vector connecting them, and then the vector PR. So we find those two vectors. Next, we're going to do the cross product of those two. The cross product gives us the area of the parallelogram, which is that area. This is the triangle, so we're going to cut in half. So in general, area of the triangle is 1/2 of the cross product of PQ cross PR. Right. Now, first find the vector PQ. PQ is P is Q minus P upon Q 6, negative 10, negative 7 upon P 1, 1 and 1. Subtract them, we have 5, negative 11 and negative 8. 5, negative 11 and negative 8. Next we find PR, final minus initial, so R minus P. R is negative 1, 2 and 1 upon P 1, 1, 1. So negative 1, that's negative 2, 1 and 0. Negative 2, 1 and 0. Right. And next we're going to find the cross product, the magnitude, and then cut that in half. So PQ cross PR. I, J, K, PQ 5, negative 11, negative 8, PR negative 2, 1 and 0. Right, 3 by 3 determinant. So the first one we're going to have, go over the row and the column, we have negative 11, negative 8, 1 and 0. That in the I component. For J, it is going to be minus 5, negative 8, negative 2 and 0 J. And then for K, 5, negative 11, negative 2, 1 times K. Right. So 0 minus negative 8, so that's AI. 0, that is 16 minus 16 with another minus. So 4 negative sides, so that is 16 J. And then 5 minus 22 minus 17 K. So that is PQ cross PR. And then we find the magnitude. PQ cross PR will be square root of a square, 16 square, negative 17 square. Alright, calculator. That's 609 with the square root, of course. Right. So the area is 1/2 PQ times QR. So that will be 1/2. So this is the area. Is 1/2 times square root of 609. So that's what we have. Next we have, I'm going to let you do number 12. It's pretty straightforward. Do you use gross V first, and whatever you have dot with W. So that should be simple. 13 and 14 will involve the parameterization of a line segment or a curve. Right. So 12 is the line segment. So first, the vector P1 and P2. If we want the line segment of P1, P2, the parameterization is equal to P1 plus T times the vector P1, P2. And then in that case, T is between negative infinity to infinity. So that means it is the whole line. Now if we only want the line segment, so only the segment of it, so just a bar. So the line segment connecting P1 and P2. So almost the same thing. Of T, we take P1 plus T times P1, P2. The only thing different here is T is going to be between 0 and 1. So this is the line segment. This is just a line. In this case, we want the line segment, so we're going to use that. So first, I'll find a vector PQ. So those. I mean P1, P2. P1, P2 is equal to P2 minus P1, P2, 0, 7, and 4. And then P1, negative 4, 7, and negative 1. Right, so we subtract them, we should have a vector 0 minus negative 4, that's positive 4, 7 minus 7, that's 0, and then 4 minus 1, that's 3. Sorry, 4 minus negative 1, that is 5. Alright, so we have the vector P1, P2. So then parameterization of the line segment P1, P2, it is going to be of T, the point P1. We can either use the parentheses or the triangular bracket. And T is between 0 and 1. Or if we want to, we can combine the components. And we write negative 4 plus 4T, 7 plus 0T, and minus 1. Plus 5T. T is between 0 and 1. So that is the parameterization of the line segment from the 0 to 1. If we want the whole line, then we say T go from negative infinity to infinity. Right, so that is parameterization of a line or line segment. Now we parameterize a function y equal to x squared. Usually for a function, this is the easiest one. all we do is, let's say we're going to choose one of them to be t. Conveniently, I would choose x to be t. So in which case, y equal to x squared, which is equal to t squared. So the curve we have is going to be x is t, y is t squared, where t is between, notice here we have x go from 1 to 3, so here we have x between 1 to 3. X is between 1 to 3, but x is exactly t, so here t is also between 1 to 3. So that is the parameterization of a function. Right. If we have y as a function of x, so let's just let x equal to t and y will follow. Okay. Next we have parameterization of a circle on the ellipse. I forgot to put that on the review, so I'm gonna prepare some other problem for it. So let's look at this set of problem. So parameterize the curve x squared over 4 plus y squared equal to 1. So naturally, when we have this type of problem, we're going to compare to some of the identities, the quick identity that we know. So for that, here why don't we match this with x over 4, x squared over 4. We're going to have cosine square plus sine square equal to 1. So naturally we can match one of them to be cosine square, one of them to be sine square, and if there's no restriction or whatsoever, usually we're going to let x equal to cosine, something cosine, and y equal to something sine. So we're going to match those two. So I will write x squared over 4 equal to cosine square and y square equal to sine square. So in this case, we take the square root on both sides. X over 2 equal, we take the square root, equal to cosine of theta, and so x equal to 2 cosine theta, and then y is just equal to sine theta. So we have RT, of course have x and y, x and then y, where x is 2 cosine theta, y is sine theta. And then for standard, it is going from 0 to 2 pi. That one complete revolution of sine cosine, one period of sine cosine. Right. Now let's just sketch this real quick. X squared over 4, easy to see that when y equal to 0, x squared over 4 is 1. I just want to write here at y equal to 0, x squared over 4 is 1, so x squared is 4 and x is plus or minus 2. At x equal to 0, y squared is 1, so y equal to plus or minus 1. So it is just an ellipse. Of course, in this case, it's not specified where it starts and in what direction it is going. So just an ellipse. The next one a little more picky. We have that is a circle or ellipse that start at the point -4 and 0. Right. So to do this, I try to get 1 to the right hand side. So I divide by 16 on both sides. So I have x squared over 16, y squared over 16 equal to 1. Again, this one has no restriction, so we're going to match 1 with cosine square, 1 with sine square. Naturally, we will match the x with the cosine. So take the square root and solve for cosine, solve for x for cosine theta. Same thing. So if y over 4 equal to sine, so y equal to 4 sine theta. Right, so we still have the same thing. RT for cosine, 4 sine. Try to sketch this real quick. When x equal to 0, y squared 16, so y equal to 4 and -4. When y equal to 0, x equal to -4 and 4, so we have a circle. But this time, it says that we have to start at this point. Nice thing about this, we don't have to go clockwise or counterclockwise. So that should be easy. All we have to do is say, in that case, we're not letting it go from 0 to 2 pi. We say it go from pi to 3 pi, or from -pi to pi. So by changing the domain of the problem, we're changing the starting point of the parameterization. Right. Next problem is a little more picky. Not only it requires the curve start at 2 and 0, it's also clockwise, which is the opposite direction of the curve we usually have. Right. So recall that from the first example we have is 2 cosine and sine. That is, in this normal orientation, that is the counterclockwise by default. Now we want clockwise, which is opposite direction of this. So what we do is just, I don't know why I write t here where it should be theta. Sorry. Now all we do is just throw in the negative sign. So it's going to be 2, instead of cosine of theta, we just say cosine of negative theta. And sine of negative theta. Now where theta increasing, negative theta decreasing, so that it will go in the clockwise direction, go opposite direction when we throw in the negative sign. Right. So it will go like this, and start at 2 and 0. So that is the standard position, 0 degree. It actually start from here. So it will go from 0 to 2 pi. So we don't change anything there. We only change, we're going to put the negative in it. Right. Of course, we can leave it like that, or cosine and sine. Cosine is an even function, sine is an odd function. So we have 2 cosine of theta, and then negative sine of theta. Right. Now let's graph this and see if it actually is what we have. Right, let's turn the calculator on. Right, to graph the polar, we're going to hit mode, make sure in the polar mode and in gradient. So we have polar, right? Y equal to sorry, not polar, parametric, sorry, because we have x and y are two different functions. So keep it in parametric radian, right? Y equal to x is 2 cosine and y is negative sine, and let's graph it. Okay, I'm going to zoom in first. If we want to graph a little slower, here we cannot really change that. Again, right, let's graph it again. It starts from this point and go clockwise, which is good, exactly what we want. Yeah, so it confirmed with the calculator there. So that one's good. So if we want opposite direction, just throw in the negative to the parameters. That would do it. If we want to start different point, just change the domain of the parameters. Now this one is very tricky. That requires have to be from 0 to 1 on the parameter. Right. The function is still the same as on the number 2. So we're going to write that curve is going to be equal to, and write exactly like we have before, will be 4 cosine theta, 4 sine theta, and theta is between 0 and 2 pi. This is what we have earlier. This one did not say where the curve starts and what direction it's going, so it should be easy. But it is between 0 and 1. So to get to 0 and 1, what we do here is, if we divide by 2 pi, it will become 1. 0 divided by anything is still 0 anyway. So that part should be easy. So we have 0 theta over 2 pi and then 1. We have exactly 0 to 1. So this must be t. So we got theta over 2 pi must be t. So theta must be 2 pi t. Right. So theta is equal to 2 pi t. So I'm going to substitute 2 pi t into theta. And finally we will have r of t equal to 4 cosine of 2 pi t, 4 sine of 2 pi t. T is between 0 and 1. Right. So of course we can check quickly. If we're going to put 0 in here, we have cosine and sine of 0. If we put 1 in here, we have sine, cosine, sine of 2 pi. So that's what we have. Right, so that is parameterization of the circle and ellipse. Now we're back to the review. So that is 13 and 14. We just write that on the list. And then I'm going to hand out that little prompt later. You don't have to turn this in, just need to practice. So we have that part. Next we have the calculus vector value function. So this should be really simple. We take derivative or we integrate. So that will be 15 so differentiate derivative at, and that is 1 over 18 times 3t squared, so at, and 1 over 6t squared. We can leave it in the answer like that or in the IJK component, just fine. Next, the unit tangent vector. This is also the tangent vector. Now we just need to take derivative and divide by its magnitude. So derivative 6t negative 24t and 8t. Now the magnitude t squared negative 24t squared and 8t squared. All of them have t squared. So 6 squared, 24 squared, and 8 squared. 6 squared, 24. 676 t squared, and square root of that is 26. Absolute values of t, but I just say t. Alright, so we take the vector divided by the magnitude. So 6 over 26 reduced by 2, that's 3 over 13, negative 12 over 13, and 4 over 13. So that is the unit tangent vector. That is the vector capital T. Right. Second derivative. That's straightforward. We take second derivative. Right. And then we have the acceleration vector. So acceleration is just like the second derivative. So I'm going to do this one instead of 17. First, we'll take derivative. Right, 8. ln of 3t is 1 over 3t. Derivative of 3t is 3. 7t cubed, 21t squared. So that is 8 over 3t, 21t squared. The second derivative, that's like t to negative 1, so we have 8 over 3, negative 1, t to negative 2, and 21t is 42t. 21t squared is 42t when we take derivative. So that is negative 8 over 3 t squared, can put t squared at the bottom, and then 42t. So pretty much we can take derivative of each component of the vector value function. The first derivative is the velocity, that's the tangent vector. If we want the unit, divide by the magnitude. So first derivative, tangent vector, velocity vector. Second derivative is acceleration vector. Right. Next, we integrate the vector value function. Right. So for that, we just need to integrate the components. So first, we're going to have 0 to 3, 1, square root of 1 plus t dt, all of that in the I component, and then minus 0 to 3, 3t square dt, that in the j component, and then plus integral from 0 to 3, 4t 1 plus t square dt, that in the k component. Right, now we just integrate each one of them. This will be easy. The first one here, I will use a substitution. U equal to t plus 1. So du is dt. And also substitution where t equal to 0. U is t plus 1. Where t equal to 1. U is, t equal to 3. U is 3 plus 1, which is 4. So that integral becomes 0 to 3. 0 to 3 becomes 1 to 4. 1 over square root. Instead of 1 plus t, I'm going to use u. dt is du, so that also du. So this one is in the I component. This one easy. 3t squared, so 3t cubed over 3, so that t cubed. Alright, this one required a substitution as well. I'll let u equal to 1 plus t squared. So du is 2t dt, and dt is du over 2t. T equal to 0, u equal to 1 t squared, t equal to 3, u equal to 1 plus 3 squared. So that looks like 10. Okay. So that integral instead of go from 0 to 3, it will go from 1 to 10. Still have 4t there on the top. The bottom 1 plus t squared, that is u square dt, that is du over 2. That in the k component. Right. So this is u to the 1 negative 1/2. So all of this is the same as equal to u to the negative 1/2. Integral of that is u to the 1/2 over 1/2. Going from 1 to 4. Alright. This is just 3 squared, so that's 27 minus 0 j. And I forgot the t here, right? So cancel the 2t. About with 2. So we have 2 u square, which is u to negative 2 because that at the bottom. So integral will be u to negative 1 over negative 1 from 1 to 10. Right. So this is just 2 square root of u. Divide by 1/2 is multiply reciprocal. So that is 2 u to the 1/2. That's square root 1 to 4 I minus 27j. This is just negative 2 u to negative 1. So that is 1 over u. 1 to 10 k. So put 4 in here, we have 2 square root of 4 minus 2 square root of 1. So that's 4 minus 1, so that could be 3. Sorry, 4 minus 2, so that's 2. I, j, and that is negative 2 over 10 minus a negative 2 over 1 k. So 4 minus 2, so 2i 27j. 2 minus 2 over 10, so 8 over 10, so 4/5. I mean 2 minus 1/5. So that would be 9/5. Okay. So 18 over 10, that is, so 9/5. Right, so we can do calculus to the vectors, the vector value function. Pretty much apply to each component of the vectors. So that was 15 to 19. Yeah, just say 15 to 19, except number 17, which is just the second derivative. And velocity and acceleration, just the first and the second derivative. So we cover that as well. Next, the next or the last topic is the arc length. So the length of a curve. So we have two forms. First, it is in the form of r of t, or the second part is the length of the polar curve. Right, first, the length of a vector value function from 1 to 2 in this case. So the formula for that is the integral from something to something. So let's go from a to b, and then we just find the magnitude of the velocity vector. So all we do is we just take derivative, find the magnitude, then integrate. So that's simple as that. So derivative give us 4t, 22t, and 10, 20t, sorry. and then the magnitude. So derivative, then find the magnitude of that vector, 4t squared, 22t squared, and 20t squared. All of them have t squared. 4 squared, 20 squared, and 22 squared. That is 900. So that's just 30t. The reason we can write 30t because t is from 1 to 2. So square root of t squared is just positive t, which is 30t. So the arc length is integral from 1 to 2. The magnitude of the tangent vector, so from 1 to 2 of 30t equal 15t squared, 1 to 2, 15 2 squared minus 15 times 1 square. So that would be 45. Right, so it's straightforward. Just the integral of the magnitude of the velocity vector or the tangent vector. Right, so that is 20. Yeah, we'll go to 21 next. Uh, 21. Find the length of the portion of directories. Alright, so we have that. Again, we find the derivative, which is 4 negative 4 sine t, 4 cosine t, and 7. Then the magnitude. Negative 4 sine t square, 4 cosine t, and then 7 square. Right. Good thing here we have cosine square and cosine square. So that gives us 16 sine square, 16 cosine square, and then 49. We have 16, factor out cosine square plus sine square. And cosine square and sine square, that is 1. So 16 and 9, 49. That is square root of 65. And then we just find the arc length. Integral from 0 to pi over 2. The magnitude, either 1 bar or 2 bar, magnitude of the tangent vector. So 0 to pi over 2, square of 65 dt. So square root of 65 t from 0 pi over 2. Put pi over 2, we have square root of 65 pi over 2. Right, so that is the arc length of for a vector value function. Next, we find the arc length of the polar curve. This is regular order, which is the function of theta. When we have r, then we're going to have x is equal to r cosine and y equal r sine. So that is the parametric form. And we go from that. Bottom line is, in this case, we have this as the function of theta. I'm going to multiply it out. 6 plus 6 cosine theta. Right. So it's slightly different. The arc length for the polar curve, the formula is going to be integral from alpha to beta. We have the function square plus the derivative. So complete a different formula. Right. So that is the curve, the carryoid. We can graph that and see what is the graph of the carryoid given by that equation look like. So calculator move here. Right. I will change this into the polar mode and still in radian. Right. Then hit y equal to 6 plus 6 cosine theta. Right. Might need to zoom out. 6. Sorry. Yeah. Even further out. Right. If we hit Windows, the theta go from 0 and 2 pi here, because pi is 3.14, 6.28 is 2 pi. So it's that indeed we go from 0 to 2 pi, as you see the graph. I want to zoom that portion only. Alright, let's zoom out this box. Yeah, you see it go one complete revolution. It go the whole curve once. Right, so it go from 0 to 2 pi. So we have the function. We just need to take the derivative and then put in the square root. So we have the function square plus the derivative square. Right, the function 6 plus 6 cosine theta square. Derivative of this is negative 6 sine theta square. Alright, so 36, 6 and 6, so that's like 32 cosine theta and 36 cosine square theta. Here we have 36 sine square again. So that should have that. And I should put the calculator away. Right, sorry. Right, so the function square, derivative square, cosine square and sine square here equal to 1. So that is 36 here. 36 and 36, that is 72. And 72 cosine theta. Right, so we have 72 and 72 cosine theta. So the arc length go from 0 to 2 pi. square root of 72 plus 72 cosine of theta d theta. Right. Now we just need to simplify this and hopefully something that we can integrate. Right. Good thing this is cosine. It will be a completely different story if it is sine and the numbers are the same, which is extremely nice. So I'm going to factor out the 72. Right. Actually, I'm going to make one change later, but for now, 1 plus cosine. Actually, it is considered this. Cosine square, the reduction of power. Cosine square is equal to 1 plus cosine of 2 theta over 2. So here we have 1 plus cosine of 2 theta equal to 2 cosine square of theta. Now, if we replace, sorry, this is still A. What I want is I turn this to theta. This to turn to theta, meaning that we're going to let 2A equal to theta. So A is theta over 2. So we're going to have 1 plus cosine of theta equal to 2 cosine square of theta over 2. So we're going to put that in there. I need to zoom out so we see the whole problem. Right, that's better. Right, then we substitute back into the arc length. Let's say L is the arc length. 0 to 2 pi. $72. That 1 plus cosine. We're going to use this. Right. There's nothing wrong there. Now this time we make one adjustment, one small adjustment here. We have to look at the graph again though. Notice that the graph is symmetric, so instead of go from 0 to 2 pi, from 0 to 2 pi, we just cut in half, the upper half and the lower half. The upper half we go from 0 to pi. So because of symmetric, on this problem we're going to go twice, but we go from 0 to pi only. Right. And that gives us square root of 144 cosine square of theta over 2. Now, we certainly can do that, but not only we can do that, but we have to do it. The reason being square root of a square here. In general, square root does not cancel the square. It only gives us the absolute values of A. So we have to guarantee that the cosine of theta over 2, it has to be positive. And if you put 0 in here, from 0 to pi, cosine of theta over 2 is positive. So we say cosine of theta over 2 is positive 40 to pi. We can check real quick. If we divide everything by 2 here, theta over 2 is in the first quadrant. And in the first quadrant, cosine is going to be positive. We need cosine to be positive, so the square root and the square will cancel out. Otherwise, it will not, and we cannot do that. Right. I think then we can continue the problem. And we say it's going to be twice as long from 0 to pi. And square root of 144, that is 12. And cosine square, because it's positive, very important, because the cosine is positive, the square and the square root cancel out. Square of 144 is 12, of course. So that will give us 24. Integral of cosine is sine of theta over 2 over 1 over 2, 0 to pi. Divided by 1/2 is multiplied reciprocal, so 24 multiplied by 2, so give us 48 sine of theta over 2, 0 to pi. If we put pi in here, sine of pi over 2 is 1, so we have 48. And put 0, sine of 0 is 0. So we just have 48. Right. So this one, it turns out to be nice when we have 1 plus cosine, which is that. We can take the square root, so that should not be any problem. But make sure that we can split, and we have to split in 2, so that we guarantee the function is positive and the square root and square can cancel out. Only then the square root and square can cancel out. Right. One more problem. Still the same formula. Arc length the function square plus derivative square this will go from 0 to 2 square root of 3. Right. Right, so the arc length here, let's say L, go from 0 to 2 square root of 3. The function is this 3 theta square. Derivative 6 theta square. I think I can zoom it back in. Right. I forgot the square inside. Sorry. That would be 9 theta to the 4th power and 36 theta square. Both of them, I can factor out 3 theta square from it. I mean 9 theta square, and then theta square plus 4. Right. We have square root of 9 theta square and square root of theta square plus 4. Right. I just split the square root. Now, remember from the last problem, square root of a square is square root do not cancel the square. It only gives us the absolute values. Same thing here. That does not cancel. However, since theta go from 0 to 2 square root of 3, theta is positive. So if it's positive, it does cancel. Let me just write as 3 theta square now again theta is positive, being from 0 to 2 square root of 3, square root and square will cancel out. So we have 0 to square of 3 theta, theta square plus 4 d theta. Right. Then that's just a simple substitution. We're going to let u equal to theta over 2. Theta square plus 4. Sorry, I'm going to wipe. So du is 2 theta d theta, and d theta is du over 2. Theta go from 0, in which case u is 4. Theta is 2 square root of 3, in which case u is 2 square root of 3. That is 12 plus 4, so 16. So do the substitution, the integral become, instead of go from 0 to 2 square root of 3, it go from 4 to 16. Still 3 theta here. Theta square plus 4, that's just u. D theta, du over 2. Right. We have a 3 here and a 2 here. 3 on the top, 2 at the bottom. Square root of, we forgot the theta here, right? We have to have the theta there. Du equal to 2 theta d theta, so d theta is du over 2. We have to have the theta there, so it will cancel with this theta, which is good. Square root of u is u to the 1/2. So we have 3/2 integral u to the 3/2 over 3/2, 4 to 16. Multiply reciprocal, that's 2/3. U to the 3/2, 4 to the 16, 4 to 16. 3/2 to 3rd cancel out, so we have u to the 3/2, 4 to 16. So we have 16 to the 3/2 minus 4 to the 3/2. 16 to the 3/2 is like 4 cubed. So that is 64. 4 to the 3/2 is 8. So 64, so that's 56. So that's what we have. So the arc length for the polar curve given by that formula, and for parametric vector value function given by this formula. And that's what all the topics we need to know for test 3. We're going to do this one in class. I hope you found this video helpful. Thank you for watching.